Hello everyone, my name is Jake Hafley, and this is kind of gonna be the video that comes before my actual Tetris project video, and I just kind of wanted to go over processing and kind of how it works, just so everyone would kind of have a better idea of how I made my game. So processing is Java. So if you work with Java, you will understand this really easily. And on their website, they have this reference page which has all of the functions and tools that you'd really need to make anything in processing. The main ones that I've used are these 2D primitive ones, like they have a circle, ellipse, line, point, rectangle, square, triangle. And so all of these are basically just shapes you can make, and then you can manipulate them however you want inside of processing. And so, how you get started in processing is your main program or your main file will have a setup function and a draw function. So, if you want to know a little bit more about those, you can look them up in here. And so, I'll enlarge this a little. So, it says that the setup function is run once when the program starts. It's used to define initial environment properties such as screen size and to load images and fonts into your program. So, in the setup function, this is the first thing you want to do is probably set the screen size. So I'm just going to kind of make a really basic application and just like draw a circle and move it around and just play with it just to kind of show you guys how you'd go about that. So in setup, you'd want to set the size. So in here, you can I normally just control F and then look up whatever I want to do because there is a lot of tools, but they are breaked up well because this is like the environment, kind of like what it said. So you can change if it's full screen, the frame rate. You can check what the current frame count is, which I've used in my Tetris project. So some examples here, you have size 200 by 100, and down here you can see the parameters. So this is kind of like a Java API. If you've coded with a lot of Java. So your first parameter is the width, and the second is the height of the screen. So the first thing I want to do is just make a basic screen that is 640 pixels by 640 pixels. So when you have your first iteration of your code done, you can hit this play button up here, and it'll open. So you see that there's nothing in this window, but by calling size, the actual window is opened and placed. And you can also do a few more things. So you can change the color of the background. So if you go to setting over here in color, and you can either use, if you do one parameter, it is it's basically based off of like how gray it is. So 255 is white, and then 0 is black. So then if we do background, let's just do like 100. It'll be kind of this like dark gray. Yeah, so this is kind of what I use from background of the Tetris game, and it is the second thing called in setup. So this setup, like its name, it's meant to be ran once and to get the general first few things, objects created, screen opened, background set, and just to really make sure your program is running. So once that's done, you can start doing things inside of draw. So draw is basically it is a loop that goes on forever, and it is kind of your like main game state. So if you want to do something in here, you could add if checks or just certain commands, really anything, and it'll just loop infinitely. So normally how you want to do stuff is you want to make other files for certain objects, and then you want to create them in setup and then manipulate them in draw. So what I'm going to do now is just make a circle, let's name it example circle, because there is a circle function, so I'm going to name it something a little different. So then in here, I don't have a class named because this is our main program, but in here I want to define a class. So then we can create this. Error on class. Why is that working? Yeah, so sometimes when I reference my other games and stuff for this a lot. Why is that? Oh yeah, I shouldn't have that there. A little small issue, but yeah. So Then how you make these classes is very similar to Java. You need a constructor to pull in parameters. So let's give this constructor, let's make an int value for the x position that we wanted at, an int value for the y position, and if you're a little stuck on what to do, you can go over here to the reference tab in processing and then see what the circle does. So you could see what you need to make a circle and to manipulate it. So then you could use that as your constructor so you know what values to pull in inside of your main or wherever else you want to create circle objects to manipulate. So you need a x coordinate for the circle, a y coordinate for the circle or ellipse, and then you need a width and height of the ellipse. So then we're going to do int width and height. So here's our constructor. So now that we have these parameters coming in, we need a way to store them. So this is object-oriented programming, very much just a lot of Java. So if you know Java, this shouldn't be much different to you. Showing and moving the objects might be a little new, so we'll just kind of keep getting through this. So we'll do int x, int y, and int width and height. So I named these the same thing as the parameters in here. So because I did that, I need to call this.x equals x. So then it specifies that this object's x parameter and not this, or this object's x variable and not this parameter. But it also just makes reading the code a lot easier because you know where each of these values are going and how they tie in to your object. So width, and so yeah, you see when you just type width, it is a keyword in processing, so you can't actually name your parameters that, or you'll have some issues. So I normally just name it width and height, or you just want to be careful about that if it lights up. So now you have a constructor, so you can make the circle, but you won't see it. So you made a constructor for the class, so you have the objects to make a circle, but this doesn't actually draw the circle inside of main. So to do that, we'll just put up here, I normally put the objects up here as global so they can be used in all the classes, because if you make it just in setup, it's hard to use in draw. So we will do example circle equals new example circle, and we'll just say it's 640 by 640, so we'll just do 200. It'll start at the x position 200 and y position 200, and it'll be 50 pixels long and tall. So actually, you know what we want to do here. So yeah, that's how we want to do that. So normally the global variables, I initialize them up top here, but then I assign them to objects in the setup. And it depends on what you're working with. You don't have to do this for every single object. You could wait to do them under certain conditions in the draw. But so like now we have this circle, but we don't have any methods to do anything with it. So like if we play this now, that circle is made and stored and the values are there, which we could run the debugger here and see that. There we go. Because when we create this, maybe we don't. I don't know. We can add some getters to check. But so the debugger is a little weird in processing. It's kind of finicky. So like a lot of object-oriented programming and with Java, you would want ways to return this information or manipulate it. In our case, if you're working with like collisions, you probably want to find ways to return the x and the y positions. But before that, we need to at least show our objects. So normally what you want to do is make a method called void show and maybe keep that consistent for all your objects, just so you know that show is what they're supposed to do every time. And so you can just call void show. You don't need any parameters. You could have them, but normally what I like to do is update how the circle is moving somewhere else, and then just have the show loop every single draw, and then have conditions for when the objects need to move, so then you can control when they're doing that, and you don't have to worry about how they're being presented. So now that we have the show, we can actually use this circle function. So now that we have a x, y, and a size, we can just call circle x, y, width, and height. So now we have this show method. So we can call that on the circle that we made. So we can do circle.show. Now, the circle isn't moving or doing anything yet because we haven't made any functions or methods or anything to manipulate it, but we should see it now. And there it is. So it is just a white circle. And there are ways to change the color of it and the stroke of it. So if you want to change the color of it, you can do fill. So fill does what you think. It fills the circle with a certain color. So you can, like I said, either do one number and it'll go from white to black. It'll just be some hue of gray. Or you can do an RGB value. So what you can do if you want specific colors, you can look them up online or use a color wheel. But I'll just put in some random numbers. So let's do like 40, 180, 70. So now this circle will not be white. It will be green. So that's how that works. And then the same rule applies to stroke. And so something you have to remember for this is if you don't specify changing the fill or stroke before you show another object, it'll be the same color. So I would always recommend defining the fill and stroke of an object before it's presented in show, because every time it tries to show another object, it will become the same color if you don't redefine it. But if you put it in the show loop, you won't have to worry about it. You can just go in here and tweak the colors or write constants up here, which is what I did, just so I could look at the top of the files and modify it. But let's just make the stroke like 100, and it'll be some form of gray. It'll probably be kind of hard to see, but yeah, it's kind of there. So yeah, that is that. So the circle is shown, and so what we want to do now is just to make our life a little easier later, maybe just add some getter methods. And so we might not necessarily use them right now, but this might be easier when you're worrying about collisions with other objects in your games, if that is something you're doing. And I just say maybe be aware of what you're doing, but it works. So if you're returning an int, if you're basically saying this is the x position of the circle, then you want to make it of a type int because it's going to send that int back to whatever's calling it. So it could just be called getX, and there's no parameters because it is a getter, so you don't want to modify anything. You just want to return this x value. And so that's not what I want to do. Also, processing is a little hard to work with sometimes with undoing stuff. I'd be a little careful with just mass pressing Control Z, because I know a few guys who I've worked with who have lost some code that way. And so naming conventions normally just capitalize the second and other words, and then make the lowercase one the first one. I also want to change these, or else you just get the X for each of them. But yeah, so these are some getters. Like I said, no parameters because you just want to pull a variable. You don't want to modify anything. But what if we do want to modify something? So what we can do is we can maybe we want to move the circle across the screen. So we could do this by calling it'd be void change x, and then we want to do so what you can do here is you want to make the method void because you're not going to return anything. You're just going to modify the internal properties of the circle object. What I've done in the past is make a constant for speed up here, but you could also add so I call it speed, but it's basically how many pixels the object is going to move. So then it's always consistently moving at the same rate, and you don't have to worry about plugging that value in. So I'm going to do that up here. I'm just going to do final int speed across, and we'll just make it 10. And then we'll do the same for across. Well, let's call it speed down, but it can move up or down. So yeah, and it's nice because these will be at the top of the class. So if you're like, the circles are moving too fast, you could slow them down by maybe changing these to 5 pixels per call. So by changing x, you can do x equals x plus speed across. And so this works. This basically adds the extra pixels that you want to move the function over. And also to specify, for using this grid system, 0, 0 is always at the top left of this, and then x goes across as it increases and y goes down as it increases. So if you're trying to move up or to the left, you want to subtract that many pixels. If you want to go down and to the right, you want to add them. That's just something to kind of think about. So and that kind of brings up a point. So you want to do change. So we'll just call this x or we'll call it move right. That'll be a little more direct. So then if you want to move it to the right, like I said, you want to add it. And if you want to move it to the left, you want to subtract that speed. And so you can do the same thing with the y. I would recommend keeping these separate. You might not always need to move all of your objects horizontally or vertically, but it's nice to not put them as the same speed, just because if something changes, then your code could get a little more complicated. So I'm just going to add this here. Y equals y minus speed down. And then when we have these methods, then we can call them on the circle object and manipulate them in draw. And so I'll show that, and then maybe user input on how to move the circle. And I think that'll kind of wrap this up well. So now we have circle.show. So even though we have these new methods to move it, we still need to keep circle.show, because if we don't include this, then we can't see how the circle is moving. But so let's just call circle dot, what were they called? We'll call move right and circle dot move down. So now when the program starts, you should see the circle go to the bottom right of the screen, and it'll go all the way off the screen because we don't have conditional checks to check the borders of the game. Yeah, so it is doing that. I don't know why it is updating like that. That's a little weird. Yeah, that is odd. Hold on here. Okay, so I found the issue. It was kind of a small little thing. So what you need to do is, when you're updating the positions, you need to redraw the background inside of this draw loop so that it refreshes every time and basically overwrites the object that is moved and placed over it. So that's why it doesn't kind of get that like streak thing now. But so we have a circle that moves, and we have getters for it. So if we did another object, we could do collisions. And so let's see here. Let's get it so I'll just make it so the circle bounces around the screen. So let's see here. Let's make 2 constants in here for these screen sizes so that we can adjust it. I guess we don't need to for this. We'll just do 640 by 640. So what we can do is, instead of doing the Boolean checks in here, we can actually do the checks inside of here. So we can call if move right. We want to see if the circle can move right. So basically, if x is less than the size of our screen, which is 640, plus speed across, and that would be, and that would be minus. So you'd want to subtract speed across, because you have to include how much it's going to move, because if you don't, then it might move just slightly into it. And then, so let's just try that. Let's see here. Okay, yeah, so you see it kind of stopped, but we'll just do that again and where you can actually see it. Oh, yeah, that's right. So this is where it gets kind of tricky with processing is the shapes. The X position is actually at the top left of the ellipse, not in the center of it. So you have to also consider that. So you want to subtract width and height. I'm pretty sure it'd be divided by 2 because you'd want to do half of it. Yeah, there we go. Okay, so yeah, it's tricky with these collisions because you have to keep track of how much you're moving and the size of the circle. So we got that. So we can apply that code to our other methods here too. So this time it'll be when x is greater than 0, if I can type 0, plus speed across plus this. Because this time you're subtracting, you're going to the left, so you're getting closer to 0. And you want to make sure the x never gets in the negative coordinates, so you want to add these because you're subtracting it. So then let's call circle.move left. And that did not work. Yeah, this is, it happens sometimes. So if x is greater than 0 plus speed across plus width and height. Why is that not working? Because x should start at 200 and then it'll just subtract. Oh, I have it up here too. Okay. Yeah. Always, read your codes carefully. So there we go. And so we can do the same thing here. So normally I just write it out like this first, just so I have the block of code and I know how I'm gonna place it first. So if you're moving up, y is getting closer to. So we'll just copy this because it's the same thing, basically. So if you're moving up, then y is getting smaller. So you want y to be greater than 0, not x. But it's the same concept, so that's why I copy it. You can save a lot of time by kind of paying attention to a lot of this stuff, because a lot of this coordinate stuff will be very similar to each other. It's just more on how you present it and how you organize it, because it can get pretty complicated pretty fast. So now we have move up and move down. We can just try those out really quick, and they should work. And I'm guessing we can just maybe make a little program to. That did not work. Oh, it's because it. Yeah, I was gonna say it moved down and then it started floating up. But it makes sense why it went past the screen, because we were only checking if y was less than 640. So if the position got negative, that check would happen, so it still kept moving down. So then we can try the actual move up method, and it should work here. So now we have this. So if we want to make a little program that bounces a circle off the edges, we can basically make booleans to where it's moving first. So we can do that in here. So we don't have to put it as parameters in here, but we could do boolean moving left equals, we'll say moving right and moving down, because that's what we started with. So I'm going to add 2 booleans for the x position or the x side and the y side. So then we can, we'll do down. So basically what we're going to do is, so what we'll do is, to move right, we need to have this check, and move right needs to be true. And so it's initially true, so this will work. Maybe. Oh, moving right. Yeah, here we go. naming conventions. I want to name it different than this method. The variable moving right. Oh, yeah, okay. I didn't put it in here. Oh, I initialize it in there. Okay, yeah, that would be my issue. So yeah, you want to place them outside your constructor so they can be used in the whole class, but you still want to assign them in here. Getting a little ahead of myself there. And then you, of course, want semicolons. So there we go. And so you want to check that it's moving right. And so basically what you can do is, and so, oh, we'll first add all these checks. So you want to move left when moving right is false because you want it to be basically moving left. And you can just save time by doing 2 booleans instead of 4 because the false and true basically invert the direction anyways. So then this one will be and not moving down, and then this one will be and moving down. So here we go. Now when this runs again, it shouldn't move because it is trying to move up. But then if we move down and we move right, it'll move. But we have an issue is it still won't bounce. And that is because when it hits this little corner, it basically won't bounce. And just to add a little fun stuff, we'll make it so the speed across is double, so it'll bounce a little more. But so basically we got to think of some like kind of pseudocode here and how we'd actually implement this. So if this check passes, so basically you are still moving right, and you can there's still room to move right, then this passes fine. But I'm gonna add an if statement to basically make it so moving right is inverted. So we'll do that. So basically this will say if there's no room to move right, then you want to invert it so moving right is false. So then you can move left. And so this will pass because then at this point, even if it's still less than 640, this will be false because you'll want to be moving left. And so you can do this. You can copy the exact same thing since you just invert it since it would be false here. And then if you can only move right, it would turn back to true. And if this stuff is kind of hard to visualize or think about all in your head, I would really recommend just getting a notepad or a piece of paper and just drawing it all out because that normally helps me a lot when I'm debugging or thinking this stuff up, because these projects do get very complicated really fast. And yeah, I kind of ran into some troubles with that in my Tetris project, but I can talk about that a little more in the next video. But the project ended up really well. It got kind of complicated by the end. Kind of wish I planned out a little more. So, oh yeah, we want this to be moving down too, or we get some weird stuff happening. And let's see. So this should work. It doesn't. Okay. So why did that work? So let's think. So it didn't actually bounce back. So the reason that it kind of fell after was because the down speed was a lot slower. So let's think here. Okay. I'm gonna pause for a second just so I can get this figured out real fast. Okay, so sorry. Took a little break there just to kind of go over my code and clean up a little bit. So I changed this so that inside of these move right, move left, there's still the if statements, but it basically just checks the position. So if x and plus the width and the height of it, so the size of it, equals 640 at the end of the screen, then moving right will equal false, and so it enables the circle to move left. And this concept applies for move left, move up, and move down, where it kind of inverts the direction it's going if it's at the edge of the screen. And so you can kind of see that now, how it kind of bounces around it. And so this is kind of how you could do collisions with other games, or you could do it another way. There's a lot of different ways to do this, and probably a lot more efficient ways. But a lot of the fun in programming and using processing is finding how you want to do it and what kind of game you want to make, because processing really does open up a lot of these tools in Java and make it a lot more accessible. So I'd really recommend it if you're kind of new to coding or you just want to make a simple program with a UI, because there also are like click events where it can basically read when a mouse is clicked, and you can also do user input by using the key pressed and key released functions. So let's see here. Yeah, here we go. So these basically allow you to set Boolean values to what specific keys you're pressing at the point, and all this is on processing site, and there's tons of forums and tools online to help. But there's a lot of really good resources to kind of make these little programs, and processing's pretty good at doing that. So thank you for watching. I hope I've kind of helped give you a general idea of how this works. This little program was kind of done just to help show you my thought process and kind of how I work through making my own game, or maybe to inspire anyone to do their own little project in it. So this video will be above my Tetris video, and if you're on desktop, you also can see my actual Tetris game right above this video. So, or I'm planning on it. But yeah, so I'll go more in depth on the Tetris project. I just thought it would be a good idea to maybe explain processing to people who haven't really done much with it, just to give them a better idea, because my Tetris code is a lot larger, so it's probably going to be a lot more overwhelming to look at. So I thought that this would help. But thanks for watching.